This is supposed to simulate a cutter cutting a slot through metal. Now, slots are a little different than most, like cutting on the side of something, because the chips are free to fly. In the slot, they're sort of captured. If the end's open, they can fly out the end and come out the top. But if something happens where they bridges across here, and what happens is that the cutter's moving along slowly, leaving more room in the back, but not nearly as much room as it needs for the chips that are building up. And before you know it, the chips are all crushing in on this thing, and then it melts. You can almost simulate it with the sheets of paper, taking it off one by one, and then every second turn, or every turn, you get two, with a two-flute cutter, you get 2 new sheets of paper. And by the time you move 3/16 of an inch forward, you've generated 30 more chips. I mean, it's just ridiculous how fast it builds up. Another thing that can cause it is if you're running around in a pocket and they get this mountain of chips around it, and the chips can no longer get flung out. They end up hitting the top of the pile and sliding back down into the pocket, and you're screwed from that time on. They just start crushing around the cutter. So that's what causes it, some sort of a blockage. Another thing that did it, I let the cutter extend further, because I had a thing here that was blocking it, and the chips would come up and bounce back and go back down the hole. And it actually made it through without galling. Another thing that helped was lift it up a little bit. And if you're cutting all the way through something, if you jack it up so that the chips can fall out the bottom, you're probably better off. Other than that, I really don't know how to fix it. Okay, we're going to try and plow through this block of metal. It's 1/4 inch end mill, 4-flute, 400 thousandths deep. It's aluminum we're cutting. High speed steel. Oh no, it's carbide, the cutter. I'll run it at 3,000 RPM. And 5 inch per minute. That was horrible. Looks like it melted all back together again. Whoops. This happens a lot when I overheat it. Guess I have to, it's just full of chips. You can see the moment that the chips begin to build up, and the sound changes immediately. Okay, now this one's a 1/4 inch cutter. I still have the same 5 inch per minute feed rate, and this is a 2-flute cutter. It's 400 thousandths deep in aluminum and 3,000 RPM. So. Couldn't make it. I'm sure it's balled up with aluminum. This picture shows some pretty interesting things. You can see that the chips are packed in there. They're oddball shaped and they're trying to crush together. And you can see around the left side of the hole there is molten material. One thing about when it melts is that it can fill up the space that nicely. That's the only way it'll fit, by melting. So it's interesting it does that on its own. So the chips just get bigger because they're curly, and they get mashed behind there, and then the cutter can't eject the chips anymore because they're so, every time it ejects one, it has to mash the rest of the pack to make room for it, and eventually it just can't do it, and the thing ends up running around in circles. Feeds and speed shouldn't have a darn thing to do with whether it galls or not, although like the depth of cut, if the depth of cut was shallow, then the chips might not be big enough to bridge across the gap, so it might not cause grief. Different feeds and speeds gives you different size chips, and maybe they'll stack up out of the slot a little better, or maybe they'll fly out of the cutter better. All these things might have a difference, but in general the problem is that the chip just gets bigger because it's curled up, and there's not much. If you block the exit even of some fraction of them, they're going to build up and pack around the cutter, so that's a real problem. It's lucky it made it through because the chips started to build up behind it. That was 0.3 instead of 0.4. It let it get chips out better. Lesson learned. Okay, this is a 1/4-inch corn cob cutter. Roughing cutter is going to produce granules instead of chips. Again, it's 5 inch per minute, 3,000 RPM, 0.4 inches deep, and it's a 4-flute cutter, I guess. Here goes. Oops, never mind, I gotta change the speed. Okay, now we can go. 3,000 RPM. Quiet as silk. Beautiful. Here's going to be the same thing, but I'm going to raise the feed rate to 7 inch per minute. Notice the grainy chips. They're not curled up like the other ones are. If you don't know what a corn cob cutter is, there's a picture of one. It's a 3/4 one. I managed to break my 1/4 one used in the video. Snapped it off. To summarize, the problem with galling is the chips are bigger than the original material. It's like popcorn, or like taking a sheet of paper and crumbling it up.
because they won't stack as nicely when they're crumbled up. So if you block the chips or enough of a portion of them from leaving the area, they'll build up and starting crowding around the cutter, so the cutter can't eject the chips until finally it's just forced to melt them. So in a slot's particularly bad because there's nowhere for the chips to go except up and out once the slot's deep enough or long enough. Depth of cut might make some difference. Generally, because the chips grow no matter what you do, no matter what feed, what speed, you got the same problem, although the particular type of chip and the size might make a difference. But flood cooling or air to blast the chips clear is certainly one way to deal with it. So there you go.